Counterfactual thinking involves imagining alternatives to real-life events and taking these alternatives into account in order to understand the true impact of an action. This can be a bit tricky to get at first, and I promise to give you a concrete example soon. For now, all that we need to understand is that counterfactual thinking involves considering what-if questions to explore hypothetical changes to reality. For example, what if I would have decided to be a professional astronaut instead of teaching this class? Exploring alternatives to reality allows us to evaluate the impact of different scenarios. Are you beginning to see why counterfactuals are a foundational concept of decision-making? Counterfactuals de facto establish what would have happened if an actor did not take an action. As such, they are key to establishing causality and understanding if what happened in reality could actually be attributed to our actions. This is still a bit tricky, so let's demonstrate based on our seeds example from before. What if we hadn't planted the seeds? Remember the graph from the previous video? It is likely that many of us implicitly assumed that staying with the old seeds, the counterfactual, the alternative to reality, would have looked like this dotted line in here. The implicit assumption here is that switching the seeds is the only thing that changes. So in the counterfactual, the trend of the chart broadly continues. However, this is not necessarily the case. In fact, in the real world, it is actually hardly ever the case. What if there was a massive rainfall in the area around the sixth measurement that was responsible for the huge rise in crop yield exhibited by the new seeds? In that case, the counterfactual would probably look different. As an example, if you're growing rice paddies, as 400 million people in Asia do, if there is a big flood, that would increase your yield drastically. If there was such a flood, it might even be the case, as we see in this hypothetical chart, that yields were supposed to grow even more, and our intervention of switching to the new seeds actually made things worse. Oh no. Now we might say, okay, maybe we got unlucky, and it just so happened that such a major event happened at the same time as our intervention. But surely, if we repeat the intervention a bunch of times and the graph always improves, then the effect of the new seeds must be real, right? Unfortunately not. There could be elements that systematically bias our results. For example, if the seed planting season is right before the wet season, then our yields will always grow drastically after our intervention. So if we don't consider counterfactuals, we might think every new seed is great, even the ones that do more harm than good. So now you might be thinking, okay, just don't be an idiot. If you know that there is a huge flood, then just take that into account and correct for that. Correcting for known variables is called controlling for these variables. But note that correcting for floods is usually not enough. What if it's not an extreme flood, but the flooding was 3 inches higher than last year, but also the temperature was 4 degrees higher, the humidity was 12% lower, and pollution was 3% worse? How do you correct for all of that? Correcting for variables is not an event that sometimes happens. It's a never-ending issue that affects all experiments. So how is it possible to understand what is a counterfactual and assess the true impact of our actions? Answering this question is a major part of the challenge in our making a difference recipe, and will indeed resolve this issue in a few units. But before we do, we need to further explore the value of counterfactual thinking.